Alright, so we're going to do a couple things here. First, we're going to find the vertex form of this equation. So right now we're in standard form. So this is f of x equals ax squared plus bx plus c. I want vertex form, which is f of x equals a times the quantity x minus h, x minus h squared plus k. That's my goal. Alright. So first, I'm going to complete the square to get this in vertex form. So to complete the square, I need a new c value. So I'm going to have f of x equals x squared plus 10x plus some new c value plus 21 and go from there. So how do I get this new c value? The c is going to be the b value divided by 2 squared, which in this case the b value is 10 divided by 2 squared, which is 25. The c value is going to be 25. I can't just add 25 to the equation, otherwise it will unbalance the equation. So if I add 25 on the right, I'm going to subtract 25 on the right. Once I'm here, I'm going to factor this part. Now this should work out to be a perfect square. So this should be f of x equals x plus 5 times x plus 5, and then 21 minus 25 is minus 4. And we'll simplify that one more time. So f of x equals x plus 5 squared minus 4. So now this is my vertex form. From vertex form, if you recall, the h and the k are the vertex. So I have my vertex form, 1. Second part of this is said find the vertex. Well, now I can get my vertex. My vertex here is I have x plus 5, so the vertex is negative 5, negative 4. And getting that from my vertex. Careful, this is x plus 5. The formula reads x minus h, so this is really x minus negative 5. So the x coordinate is negative 5, the y coordinate is negative 4. Once I have that, then it asks me for the axis of symmetry. So I'm going to abbreviate the axis of symmetry as AOS. Axis of symmetry is an equation, and that's going to be x equals, and whatever the x value is, negative 5. Next is the direction of opening. Well, going from my standard form or vertex form, the a value is positive. So the opening is going to be a parabola going up. The y-intercept, I'm going to get the y-intercept from my standard form. So in standard form, the 21 is the y-intercept. So, or if you wanted to plug in 0 for x, and you'll see f of 0 equals 21. So the y-intercept is 0, 21. X-intercepts. There's two methods I want you guys to use. Quadratic formula for the odds and completing the square for the even. I'm going to demonstrate both on this one. All right. For the quadratic formula, okay, I'm going to go off of my standard form. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a, and I'm going to plug in. So I got x equals negative 10 plus or minus 10 squared minus 4 times a times c all over 2 times a. Simplify this. X equals negative 10 plus or minus square root of 100 minus 84 over 2, which turns into x equals negative 10 plus or minus square root of 16 over 2. X equals negative 10 plus or minus 4 over 2. And now we can get our intercepts. Negative 10 plus 4 is negative 6. Negative 6 divided by 2 is negative 3. Or x equals negative 10 minus 4 is negative 14. Divided by 2 is negative 7. Okay? This is using the quadratic formula. Our second option is here for our intercepts if we used our vertex form. So the vertex form was here. So we have x plus 5 squared minus 4, and we set it equal to 0. Alright, so this is using completing the square. So we completed the square already. We're looking for intercepts, so we set the y value, or f of x, equal to 0. Add 4 to both sides. X plus 5 squared equals 4. Square root both sides. X plus 5 equals plus or minus 2. X equals negative 5 plus or minus 2. X equals negative 5 plus 2, which is negative 3. X equals negative 5 minus 2, which is negative 7. And those are your intercepts using both methods. We have our intercepts. Now this next part is asking me for transformations. Transformations I'm going to get from my vertex form. So this is going to be number 7, transformations. So I have, let's see, my A value is 1, so I got no vertical stretch or shrink. My B value is 1, no horizontal stretch or shrink. My H is, so I have a horizontal shift, 5 units left, and I have a minus 4, so I have a vertical shift, 4 down. Alright, there's my transformations, and again I'm getting that from my vertex form. State the domain and range. Okay, so we got number 8 here. Domain, range. Okay. At this point, when you're asking for domain and range, if you want to graph it, I would graph it now. That might be a nice little strategy for you guys, just to get an idea what the graph is, because you have a lot of information already. But the domain and range here is negative infinity to infinity, because I could substitute any x value I want into the function. The range is how low is the graph going to go. Well, we have my vertex. The vertex will be the minimum value, so it's going to go as low as negative 4, and it's going to rise up to infinity. All right, so let's take a second and actually graph this one. So a little correction here on the range. This actually should be a bracket because it's including this. So before I answer the next questions of domain and range and the intervals where it's increasing and decreasing, I'm going to take a second and graph this. So I could graph from a standard form or vertex form. So I know my vertex is negative 5, negative 4, so I can plot that point first. 1, 2, 3, 4, 5. 1, 2, 3, 4. There's my vertex. My x-intercepts are negative 3 and negative 7, so 1, 2, 3, 4, 5, 6, 7. My y-intercept is way off the graph on this one, so I can graph this like this. So I have an idea where my u value is. So this is the shape of my graph. So if I'm going to flip back and forth between screens. So if I'm looking at this, the next question says domain and range. Identify the interval where f of x is greater than 0. So if we're looking at where f of x is greater than 0, all right, so that's where my graph is above the x-axis. So where it's above this axis. So where is it above this axis? It is greater than 0 on the interval. So f of x is greater than 0 at the interval negative infinity to my x-intercept, and the x-intercept is negative 7. Then it falls below the graph, union, and it starts up again at the intercept 3 to infinity. So if we look at that again, so it's greater than 0 here, and it's greater than 0 here. So from negative infinity to the x-intercept of negative 7, and it starts again at negative 3 to infinity. Where is f of x less than 0? So looking at my graph, where is it less than 0? It's less than 0 from here to here. So on the interval, negative 7 to negative 3. If it said less than or equal to 0, then this would be, what would be the difference here? If it said less than or equal to 0. Yep, then these parentheses would turn into brackets. So now we have our intervals. Also then, where is the function increasing and decreasing? Increasing and decreasing. Look at my graph. It's decreasing from here all the way to the vertex. So it's decreasing from negative infinity all the way to negative, we always use the vertex, use the x value of the vertex, which is negative 5. That's where it's decreasing. Where is it increasing? From the vertex and to infinity. is we're increasing, right? So using the x value of the vertex. Find the average rate of change on h plus 3. So what do I mean by that? I'm saying find the average rate of change. So I'm just going to write average. So on the interval, well, we said our vertex was -5. That's the h value. And I said just add 3 to it. If you add 3 to it, you get -2. So what is f of -5? That we have already, which is -4. And then what is f of -2? We get 5. And if we find the slope between these two numbers, we get 5 plus 4 over -2 plus 5, and we get a slope of 3. So the average rate of change here is 3. One more piece, I believe. Average rate of change. And then if f of x equals 10, find x, then x equals question mark. You can take either one of these. I'm going to take my vertex form. So my vertex form was x plus 5 squared minus 4. And I'm going to say, when does this equal 10? I'm going to add 4 to both sides. So I get x plus 5 squared equals 14. Square root both sides. X plus 5 equals plus or minus the square root of 14. Can I simplify the square root of 14? Nope. X equals -5 plus or minus the square root of 14. That is when. So I'm asking, when does it equal 10? So on my graph here, when does my U shape cross or intersect with that line, y equals 10, and it crosses at those coordinates there. Does it work out to be perfectly? No, they're decimals. It's irrational, no big deal. And the other one was, when does f of x equal -10? Well, if you look at your graph, will this graph go down as low as -10? Nope. So in this case, you could just say no solution, because they do not intersect.